Before we continue with the coding of our app, we need to discuss what a database is and why we'd actually want to use one. Android and iOS both come with a native SQLite database support. And in almost every app, without exception, that you're going to make, you're going to have to store data. And in most cases, that data is not just of one type. There are lots of types of data. So you may have these rectangular bricks of data, you may have circular ones, and you may have various other kinds. Now, it would be very difficult to store these in, say, a text file, for example, because you'd have to convert everything to strings and then store it away as that, and when you got it back out, you'd have to convert back to numbers, etc. So the solution to this is a database. And if you think of the big blue base as the database, what it can do is it can store all those bits of data for you in these sort of native strings, integers, that kind of thing. And databases also give you a lot of power over how you access these things. So you can ask a database, give me this list of stuff with all of these different variables, and I want you to order it in a certain way. So for example, order it in a way that puts it by date it was entered, or by size of string, or by name. There's lots and lots of ways of chopping the data. So SQLite databases are absolutely essential for apps. And if you think of SQLite databases as the vital data connection between itself and the actual app on the phone, you'll be set. And once you've written a decent SQLite database class and various methods, you can then simply just copy and paste that in future projects, check it works, but once you've got your decent class going, you'll never really have to rewrite it. Let's use a component to access the databases on our devices. We could write the code from the ground up, but there's no reason to, because there are so many components out there that we can leverage to shortcut our development time. Now, the component we're going to use is stored on NuGet. So if you double-click Packages in your shared project or your PCL, and then in the search box, search for SQLite Net PCL, and this should come up with the one that we're after. And if we look down here, this is the one we want. We want the ID to be SQLite-net-PCL, and it specifically mentions Xamarin in the top there. So let's add that package to the shared project, and we want to add the same package to the Droid project. So it should be at the top of your list now. Click Add Package, and we want to do it in iOS. And there we go. And so just give it half a minute to actually install those. And in the next lecture, we'll actually look at implementing this package and using it to access databases. The very first thing we have to do to access our databases in a cross-platform manner is to declare an interface. So let's right-click the shared PCL, click Add New File, and we want a general empty class, and let's call this iSQL Lite, and hit enter. And then we want to change this class to an interface. So an interface, iSQL Lite. And then inside here, let's get rid of this constructor. And we want, first of all, come up to the top and let's insert a using SQLite, because we need that. Then down here, start typing SQLite connection get connection. And the reason we need this interface is because databases are stored in different locations on Android and iOS. So this interface allows us to talk to the individual iOS and Android projects and actually get a connection to the database. Once we have that connection, then actually putting things into the database can be done in a shared project sort of way because the code would be the same. So let's save that. So to go along with that, let's first insert the database connection inside our Android project. So come down to Android, right click it, click Add, New File, and again we want an empty class, and let's call this SQLite and then underscore Android. And hit enter and it's created for us. Now we're going to leave this as a class, but at the top we need to add some usings. So first we need to add system.io because we're going to be accessing a file, so we need to access input output. And then of course we have a using Xamarin.forms, and that's all we need. Now what we need up here is some kind of declaration that tells us this is a dependency of something else that exists in our PCL. And the way we do that is by typing assembly, inside square brackets this is, semicolon, dependency, that should be a capital D, dependency, and this dependency has a type of, and then in brackets we want just do it x10 dot droid dot SQLite underscore Android, and then close off all your brackets and make sure they're correct. Okay, so once we've done that, let's come down into our class, and under SQLite Android we're actually going to define a region. So put a hashtag in and region SQLite, and we want to say this is an implementation, and then in here we're actually going to write the code that allows us to get this connection. So SQLite connection, SQLite connection, and this is going to be the get connection that our iSQLite actually referenced in the shared project. So it's going to come over to Android, find this, and it's going to go down here and actually get the connection for us. So in here we need a var file name, and this is going to be database.db3 as the extension, and then we need a var documents path, and this is the internal documents path for our app, and the way we get that is by environment dot get folder path, and we want environment dot special folder dot personal. So we've got many options here, but we want to keep this secret from other apps, so special folder dot personal. Close off your brackets. Then we need to create the path of the documents path and the file name together. So we say var path is equal to path dot combine, and then we have to pass it two paths, so of course the documents path and the file name, and what that's going to do is actually blend those together and give us a path to the database. And then we have to open up a connection, so var connection is equal to a new SQLite dot SQLite connection, and this asks us for a path, which we just created, and store time as ticks. Let's have that as true, and close it off. And then finally, we have to give this connection back, so we want to return the connection, because up here in our public declaration, we said we're going to pass back something of this type, an SQLite connection. And then underneath here, we're going to close off this region, so we say end region. And that sums up the entirety of the Android portion of accessing the SQLite database. Let's do the same on iOS. So come down to iOS project, right click, add a new file, and we want SQLite _ iOS, and take note of the capitalizations there, and hit enter, and you'll be very glad to know this is extremely similar to the Android version. So we need some using our system.io and using xamarin.forms, and then we need our assembly declaration, so assembly, and this is a dependency, which of course has a type of, open the brackets, just do it x10 dot, and we want iOS, because it's going to come and look at this namespace, dot SQLite _ iOS. Close off your brackets, and that does that. And then down here, we want this class to actually inherit from iSQLite. Let me just check we've done that in Android. We haven't. I knew I'd forgotten something. iSQLite. There we go. So here we are in the iOS one. In the iOS one, we again want to go past this constructor and create a region and create some access code. So what we can do actually is just copy the Android code straight over to here. So I can drop it in. I've pressed copy on an empty space, so it's copied nothing. Command C, let's drop that in. There we go. So again, we have our get connection, we have a file name, and that's going to be the same as before. And here, again, this is the same because it goes and finds the personal folder for this app on iOS. And then this is going to be slightly different. In fact, before here, we need to have a library path. So under documents path, let's have var library path is equal to path dot combine, and we need to open up the documents path, and we actually need to add 2 dots, and this is related to the file system that's in operation on iOS. Don't worry about it now, but just know we need it for this. And then we want to open up a library folder and close that off. And then in the next line under path, instead of documents path, we actually want library path. And then everything is the same as before. We create a connection and we return that connection. Now I'm just going to scroll up, and I have an issue here. It says we have a problem. Let's just see what it is. SQLite. That's because here I need to capitalize this L. I've made a slight error. You've got to watch out for this when you're programming, as this capitalization really matters. Okay, now just to recap, inside our shared project, way at the top here, we created an SQLite. And this says, this is an interface. I want you to go off into the Android and iOS projects and Windows Phone if you have it. And I want you to get connection. So it wanders over here, finds this dependency, and grabs the connection for us, both for Android and iOS. In the last lecture, we created a connection to our database, or an interface. So we had this in our shared project, and we looked at Android and iOS and got the database connection. So I'm just going to close these up. And what we have to create now is some code to actually access our database, to insert things, delete things, and get a list of things we generally have inside there. So under Just Do It X10, let's right click and add a new file. We want an empty class, and let's call this database. Now this class is going to hold all of the code to access the database. So to do that, we need some using statements. Of course, we'll be using SQLite. We'll be using Xamarin Forms. We'll actually be using system.collections.generic because we're going to need lists, and using system.link to do some fancy conversions and various other things with link because it's really useful. Okay, down here inside our class, the first thing we need is a class level variable, and this is going to be private, so nothing else can access it, SQLite connection, and then type underscore connection. The underscore has no relevance, it's just part of the variable name. Inside database, which is our initializer, we have to create that connection. So underscore connection is equal to dependency service dot get, and then we want a type of ISQLite dot get connection. So that code we wrote in the last lecture is now coming into play here to allow us to fetch this connection. If we try to access a database and a table in that database and it doesn't exist, we're going to have a problem. The way around that with SQLite databases is to actually create the table each time you access it. It'll only create the table if it doesn't exist. So if you hit create table and you already have data in there, nothing will be done, nothing will be changed. And we want to create a table, and this table is going to be our to-do list item. And this is turning up red because we haven't actually created it yet, but we're going to get there. Then we need a method to actually get the to-do items. So let's say public, and we want a list returned from this, and again we want a to-do list item, and we want to call this get to-do items and create our method. And then this is simply one line of code, and we're going to return from tin underscore connection dot table, and we want to check this table, so I'm going to copy this word there, and we want to select those items, and we want to cast them to a list, to list. So what this does, it gets all of our to-do items from this connection and this table. Then of course we need to actually add a to-do item. So let's have public void, because we're going to return nothing from this, add to do item, and this will be a type of to-do list item, and this code is simple enough. We say connection dot insert, and we pass it the item. And then, just for convenience, if we have a whole bunch of things that we want to add, we can create another method which will be public void add to do items with an S, and this we're going to pass a list of our to-do list item, and we will call this list items. Open our braces, close them, and then in here we're going to use a C# feature which is for each, so it goes through each item in this list of items. So we will say open brackets var item in items, and then underscore connection dot insert item, and close it off. So just to reiterate, this for each is going to go through each and every one of these, and every time it gets one, it's going to insert it into the database. That should be all we need for now. The next thing we have to do is actually create this data model that I've referred to here, to-do list item, and that's what we'll do in the next lecture. In the last lecture, we created our database code, and we made a reference to these to-do list item objects. Now these are known as a data model. They are simply a container to hold a bunch of data to do with our to-do list. So what we have to do is create a class for that. Right-click our shared project, add new file. We want an empty class, and we will call this to-do list item, and hit new. Remove the constructor inside the class, so we're just left with the class. Now this is going to make use of the SQLite part of our project, the database part. So we have to have a using SQLite statement. Then inside the class, the very first thing we have to have is a public integer ID. And we're going to have a get and a set that allows us to access it. The reason we have an ID is because SQLite databases rely on unique identifiers, and they are usually called an ID, and they are usually an integer. And above this line, we have to add some more properties to this integer, the first of which is called primary key. So if you tell your database, go and look up this ID, it knows to look up this actual parameter. We need one more, and that is called auto increment. And auto increment has a look at your current database and all of the IDs, and it finds the highest one in terms of a number. And if your highest one is, say, 10, it will then give the next one a value of 11. So you never have to worry about actually assigning this ID. These items up here will automatically assign the next one up for you. So now we need some variables to actually hold our to-do list items. And the first one we need is a public string. And this is going to be our title. And we need a get and set so we can access it. And then we need another public string, and this will be the content of our to-do list items, so the notes, if you like. And we need to get and set that. Finally, we need another string, and this is called alpha. And this is going to do something quite clever. It's going to set the opacity or the see-throughness of each cell in our table. And I'll cover that a little bit later on as we get into the fine-tuning of our app. But for now, just know that's what it's going to do, and we have to have a get and set for it. And save that. So that completes the data model. And if you close that, now all of these have turned to blue, and we no longer have any reds. In the next lecture, because we've now created everything, we're actually going to insert some default values into our database, and then we're going to show those default values inside our list view. we have a database, we have a model for our to-do list item, and now we need to connect those to the actual list view in our app. To do that, let's open up our main page.xaml.cs, and then inside here, under the constructor, before initialize, or rather after initialize component, first we have to check there's actually something in our database. Otherwise we'll get a horrible error if there isn't. So let's just say check database populated, like that. And then if we've checked that it's populated, then we can actually assign some things to our list view. So type list view, and now this variable name is being pulled from main page.xaml here. So list view dot, and we need an items source, because every list needs a source of data, like a well of data, to actually put inside its cells. And to do this, we're going to have another method that we haven't created yet, which is get to do list. Right, so we have two red methods. Let's create them. The very first one we want to create is check the database is populated. So let's have void, and let's copy that down to here and create our method. And then it turns to a normal color. So what we're going to do in here is check if the database is empty. If it is, we're going to put in some default values so we don't get any errors. And the first thing we do is say if, and then we want to grab a connection to our database, so new database dot get to do items, and this gets a list of items in the database. And then we have to count those, so dot count. And if that is less than 1, that means we have no items. I would like you to perform the following code. And so I'm just going to put a comment here, which is fill up database with default. So the first thing we have to do is create a list of the things that we're going to create. So var items is equal to a new list, and this list needs a type, which is to do list item, and initialize it. Now we need to add some things to that list. So for int I is equal to 0 until I is less than 10, I plus plus. And what that's going to do is actually take me in a for loop, and it's going to count I one by one every time it goes around until it reaches I is 9 or less than 10. And that means, because we start at 0, I is actually going to go around 10 times. This loop is going to run 10 times. And because our app has 10 to-do list items, that's perfect. So each time it runs through, we want to add something to our items. So we say items dot add, open our brackets, and then on a new line, just so it's clear, we say we want you to create a new to-do list item. Open brackets, open brace, and I would like you to give this a title of task space quote, and then plus, and then in brackets we're going to say I plus 1. And why do we do that? Because I want this to say task 1 every time it goes round, then task 2, then task 3. But I actually starts on 0 and ends on 9. So if I left it without the plus 1, it would say I0, I1, I2 up to I9, or task 9 rather. But if I add the 1, then it's correct. And then of course I have to change that, because it's currently a number, to a string. And then comma. Then I have to give it some content, and that's equal to description and let's have dash tap to edit and then a comma. And we had one last thing, which was alpha. And we're going to do some neat maths here. Alpha goes from 0 to 1. So 0 means your item is see-through, 1 means it's opaque. So we have to subtract 1 minus, and then open two brackets and type double I, because we have to cast this I to a double, because that's what alpha expects. I, and then we're going to divide it by 20. So if you think about it, every time we go around this loop, we're saying 0 over 20, 1 over 20, 2 over 20. And then we're saying 1 minus that value. So the alpha is slowly decreasing as we go round and round this loop. So let's close off that bracket and close off the final bracket, and then because it's a number and we need a string, we say dot to string. And then close off the initialization of our item and close off that bracket. There we go, everything has turned to the correct color. Now we have a list of items. What we want to do is, under this for loop, add these to the database. So say new database dot add to do items, and then pass it the list that we just created. And that should sort that out. Now we need to create our get to do list. So let's copy that, come down here, and this is going to pass back a list of to-do list items. Open our brackets, create our method. And this is just a couple of lines, which is var items is equal to new database, open brackets, dot get to do items, and this passes back a list. And then finally we have to return those items. So coming up to our constructor, whenever we jump into here, everything gets initialized. It checks the database is populated. So if it isn't, it will actually populate it for us. So this really is only going to happen the very first time we load the app. After that, this will always have some items, so it'll never run again. Then it's going to jump to our list view and set its items as whatever it gets from get to do list, which will be the items from our database. Let's hit play and actually test that. And it should pre-populate our database and then show us our list of things. Now if you recall, that alpha that we set is slowly decreasing. It's slowly getting lower and lower. And what's happened here is, if I come back to Xamarin and stop it running, in our main page.xaml, with our image, we set our opacity as a binding to alpha. So it went off, found that alpha attribute, and bound it to it. And of course, it goes without saying, it's also binding this title and content from the data model that we've created. Okay, that is how you insert database items and get them out again and display them in a list view. In the next section, we're actually going to look at wiring a bit more up to this app and making it a little more functional.